the smallest square number that is divisible by each of 2, 3 and 8 is. So we have given certain square numbers 64, 144, 1296, 576 and so on. So we need to check from among them which of the numbers is divisible by 2, 3 and 4. It should be divisible by 2, it should be divisible by 3 and 4. So it is something like this. It should be happens like this. So to see this, we need to find the LCM of 2, 3 and 8. So we know that the LCM of 2, 3 and 8, I can express this as 2 into 3 into 8 is nothing but 2 cube. So how can you find the LCM? Among this, we are comparing the highest powers. So here we have 2, here also we have 2. Among them, the highest power is 3. So we are taking 2 raised to 3 outside. Similarly, here there is a term which is 3, which is accompanied by no 1. So 2 raised to 3 multiplied with 3. So we have 2 raised to 3 multiplied with 3, which implies 2 raised to 3, that is equal to 24, 8 into 3, that is equal to 24. So the LCM of this number, that is equal to 24. Now among them, find which of the smallest number that is divisible by 24. Of course, we know 64 is not divisible by 24. We can check for 144. Of course, 144 that is divisible by 24, hence, and the rest of the numbers, they are all higher than 144. So we can say that 144 is the least number which is divisible by 2, 3 and 8. Next one, cube of 24 is. So what happens? See, 24, the units place of 24, that is 4. So what is 4 multiplied with 4 multiplied with 4? If you are cubing some number, we are multiplying that number 3 times. So what we are doing is 24 multiplied with 24 multiplied with 24. But we are only interested in finding the units place. So here the units place is accompanied by 4. So I can see the options whether there exists a number such that the cube of that number must be equal to 4 cube. So we know that 4 cube, that is equal to 4 into 4 into 4. What is 4 into 4? It is 16. What is 16 into 4? It is 24. So the units place must be equal to 4. So among them, which of the number is the units place equal to 4? You can see that is equal to 1, 3, 8, 2, 4. And rest all numbers are different, which is not equal to 4. So the cube of that particular number must be equal to 1, 3, 8, 2, 4. Which is equal to, that must be equal to 4. So this is our option. Next one, which of the following number is a perfect cube? The first number, that is 243. So we can prime factorize 243, which is equal to 81, again that is equal to 21, again which is equal to 3. So 243, that can be expressed as, we have 1, 2, 3, 4, 5. So that is equal to 3 into 3 into 3 into 3 into 3. So to make this as a perfect cube, we need one more 3, right? Here we need to group them among 3. So 3 into 3 into 3, here is one pair, so we can pick 3 outside. From here we need another 3. So we lack a 3 here. So this one is not a perfect cube. 243 is not a perfect cube. Next one, 512. So as usual, we can factorize 512. It can be expressed as 2, 256, 128, 64, 32, 16, 8, 4 and 2. So here we have 3 2's. Here also I group them as 3. Here also you can see 3. So we have 2 raised to 9, which is equal to 2 cube into 2 cube into 2 cube. Again we can write them as something like this. Okay, from this pair, from this group I can take 2 outside. From this also I can take 2 outside. From this also I can take 2 outside, because we are grouping them with 3's, since we are interested in finding cube. Rather, if we are interested in finding squares, we are going for pairs. That means we are, from a group we are picking 1, and the group consists of 2 elements. Here we have 3 elements. In a group there must be 3 elements. So here we have 2, here we have 2, 2. So 2 into 2 into 2, which is equal to 8. So 8 cube, that is equal to 512. We can go for next one. Yes, this is a perfect cube. 392. You can factorize 392, which is equal to 196, again which is equal to 98 and 7. So 392, which is equal to 2 into 2 into 2 and 7 into 7. So here also we lack a 7. If we have a 7 over there, then this turns to be a perfect cube. So this is equal to, while grouping we have only 2 as a pair, so we lack for 7, so this is not a perfect cube. Next one, 8640. 8640 on factorization, that is equal to 24320, 2160. Again on 2 we have 540. Again on divisible by division by 2 we have 270, 135, 5, 9 and 3. Okay. So I'm grouping this number 8640 that can be written as 2 raised to 6. You can see 1, 2, 3, 4, 5, 6. 2 raised to 6 multiplied with 3 raised to 3 multiplied with 5. You can see for 5 we lack 25. That means for 5, to make 5 as a group we need 25 too. So basically this is not a perfect square. On simplification we can group them as, we have 3 groups but no group for 5. The room is empty, so this is not a perfect square. I mean, this is not a perfect cube. Next one, which of the following number is not a perfect cube? So from that, 216, 343, 125, 667. So we can see someone. These all are non-numbers. 216, that is the cube root of 6 cube. 6 cube is equal to 216. And 343, that is equal to 7 cube. 125, that is equal to 5 cube. But there does not exist a number such that the cube of such numbers, a natural number, that is equal to 667. So you can say that 667, that's not a perfect cube. Now, which of the following is the cube of an even natural number? So basically you can see an cube of an even natural number, that number must be equal to an even number. So among this, which of the number is even? 1331, it's not even. 4913, that also is not even. 3375, it's also not even. 1728, it's an even number. So the only number is 1728. Hence we can say that it is 1728.